Okay, so we're going to have a look at nth term in this lesson. Nth term is all to do with sequences. You can either generate a sequence using an nth term or find the nth term from a sequence. So, because it's something we've seen before, we're going to do a little starter on it. I'll just talk you through the first one and then you can have a go at the rest. Okay, so each question is a rule that gives us a different sequence. I would like us to find the first 5 terms of the sequences. So what you have to do, if I wanted to find the very first term in a sequence, n would always be substituted in as 1. If I wanted to find the second number in the sequence, n would be substituted in as 2. If I wanted the third number in the sequence, n would be 3, and so on. So for this first question here, I want to find the first 5 terms of the sequence. So I'm going to put n is 1, 2, 3, 4, and 5 in 5 separate calculations. So for the first one, because 2n means 2 times whatever n is, I would do 2 times 1 equals 2. So 2 is the first number in my sequence. The second number in my sequence would be 2 times 2. N would become 2 because I wanted the second number in the sequence. So that would give me 4. For the third number in the sequence, I do 2 times 3, which gives me 6. Fourth number, 2 times 4, which would give 8. And then finally, 2 times 5, which would give me 10. Okay, so that's what you have to do for the 2, 3, and 4. Now for question 5, it asks you to find the 50th number of the sequence and the 100th number. So for the 50th number, I would do n in as 50. So 3 times 50 adds 6. For the 100th term, 3 times 100 adds 6. So what I would suggest now, if you pause the video, have a go at those questions, and then I'll display the answers. Okay, so pause now and have a go. Okay, so hopefully you've had a little go at those questions, and these should be the answers. This is the one I did with you, so you should have had 2, 4, 6, 8, 10. Next one, and so on. Okay, right, what we're going to do now is have a look at something that's slightly a bit harder. So this one is n squared. So this is what we call a quadratic sequence because it has a squared term in it. So we have to apply the same principles. If I want to find the first 3 terms, then I would put n in as 1, n in as 2, n in as 3. So we've got to be slightly a bit more careful because we have to think about the rules of BIDMAS. So if I substitute in n in as 1 and for the first number, I'd get 5 times 1 squared plus 1. Now remember, with the rules of BIDMAS, I would do brackets first where there are none, but then there's indices. Now in this case, there are indices, the power here. So I would do the 1 squared first, then the multiplication, then the addition. So 1 squared is 1. 1 times 5 is 5. Add 1 to give that the first term is 6. The second term then, n would become 2. So this time I do 5 times 2 squared. Add 1. So 2 squared is 4. 4 times 5 is 20. Add the 1 gives us our second term is 21. And then for the third term in the sequence, n would become 3. So I do 5 times 3 squared. Add 1. So 3 squared is 9. 9 times 5 is 45. Add 1, 46. Okay, so you can see the 3 numbers in the sequence. 6, 21, 46. Right, I'm going to put some up for you to have a little go at. So if you press pause, have a go at the questions. You have to find the first 3 in the first 3 questions. And then for 4 and 5, you have to find the 15th and the 50th. So n would have to be 15, n would have to be 50. Okay, be careful on this one. 3n squared means you square n first, then multiply it by the 3. Okay, have a little go, see what you get, and I'll put the answers up. Okay, hopefully you've had a little go at these ones then. So, answers for the first one, second one, third one. I told you to be careful with this one. If I substitute n in as 1 for the first term, 1 squared is 1, multiplied by 3 is 3, subtract 10 to give you minus 7. Okay, same with the bottom one here. So I would do 50 squared times that by 2, subtract 4. Okay, hopefully you got those right. If not, go back and have another little look. Listen to the examples and see if you can see where you've gone wrong. Okay, what we're going to do now then is have a look and see if we can find the nth term of different sequences. Now these ones are slightly easier. These are called linear sequences. Now the reason why they're called linear sequences is if we have a look at the gap between each number, they go up or down in the same gap. So on this one, I've got 5 to 7. Well, I'm adding 2. 7 to 9, again, adding 2. 9 to 11, adding 2. So that means that my rule has got something to do with the 2 times table. And therefore, I write down 2n. So the gap here is the number in front of the n. Now, 2n is not my rule because 2n would give me 2, 4, 6, 8, 10. So that is not what my sequence is. But if I write that sequence above, what does 2n give me? Well, it gives me 2, 4, 6, 8, and 10. Now, if we can have a look and see, what do I have to do to the 2 to get to 5? 4 to 7, 6 to 9, 8 to 11, 10 to 13. Well, every time I have to add 3. So the rule for this sequence is 2n add 3. 2n because I go up in 2s, add 3 because I have to go from the 2 times table to 5, which is adding 3. Right, have a look at the next one then. This one, if you notice, it's still a linear sequence. However, it is decreasing. So every time we are subtracting 5 to get to the next number. So minus 5 every time. Now, that's the gap. So that is what I write down in front of the n. So my rule has got something to do with minus 5n. So minus 5n would actually give me the minus 5 times table. Minus 5, minus 10, minus 15, and so on. So if we look and see, what do I have to do from the number in the sequence? I should say from minus 5 to the number in the sequence. Well, minus 5 add 19 gives me 14. So I have to add 19 on to minus 5n to get the number in the sequence. So the rule is minus 5n add 19. Let's check it with the second one. To go from minus 10 to 9, well, yeah, I have to add 19 to it. Okay, so those are linear sequences because the gap is the same. We're now going to have a little look at what we call a quadratic sequence. Okay, we looked at those a little bit before when we were generating sequences. So the clue that is not linear is that the gap will be different. So if you have a look at this sequence 2, 5, 10, 17, the gap is different. For the first one, I have to add 3. The second, I have to add 5. The third, I have to add 7. So you can see that the gap is different. So what we do now is we look at something called the second difference, which is the difference between the gaps. So in this case, it is 2. There is 2 between 3 and 5. There is 2 between 5 and 7. Now that number there tells me that the rule has something to do with n squared. So when the gap of the gap, the difference of the difference is 2, then n squared is somewhere in our rule. So now I need to think, well, the rule n squared would give me the sequence 1, 1 times 1, 4, 2 times 2, 9, 3 times 3, and 16, 4 times 4, and so on. Okay, so what do I have to do to n squared to get the number in the sequence? Well, 1 to 2, I need to add 1, 4 to 5, I need to add 1, 9 to 10, and so on. So my rule for this sequence is n squared, add 1. Okay, so I'm going to put some up for you to have a little go at. Pause the video, have a go at the questions, and then I'll display the answers after. Okay, here we go. Okay, so hopefully you've had a little go. These included quadratics with the n squared and also linear. So hopefully you've seen the difference between the two. So I'm going to show you the answers. Have a little look. Hopefully you got them right. If you didn't, go back, have a little look at the example again and see if you can see where you went wrong. If not, email me and I can check it with you and try to help you. Okay, well done all.